What's up? I'm Van, and today I want to show how to use the quotient rule. We're going to go through these 5 examples here, so let's get started. So for question 1, we want to take the derivative of f of x, and we have natural log x over tangent x. Now, when you're new to quotient rule, I highly recommend that you define u and v and use the formula here for finding the derivative. So u is always going to be your numerator function, and in this case, u is equal to natural log x. And then the denominator function v we could call tangent x. So then we just have to know the derivative of each of these pieces. So we would have u prime is going to be 1 over x, and we have v prime is equal to secant squared x. So then when we want to use the quotient rule, we're just going to apply this formula. Just be careful not to do the derivative of the numerator over the derivative of the denominator. That's a very common mistake when people forget quotient rule. We just have to remember to use this entire thing here. So we have v times u prime. So we're multiplying tangent x times 1 over x. So we're going to have tangent x times 1 over x. And then we have minus, we're doing uv prime, which is going to be the product of these two. We're going to have natural log x times secant squared x. And all of this is being divided by v squared. And v is our denominator function tangent. So we have tangent squared x on bottom. Now, the only thing I would do here to simplify this a little bit more is that 1 over x piece is a little bit sloppy. So maybe we would want to multiply by x over x. And that's going to give us, we're going to have tangent x, because multiplying 1 over x by x is going to simplify nice. And we're going to have minus, and we're going to have x times natural log x secant squared x. And in the denominator here, we're just going to have x times tangent squared x. So this is our derivative for the first example. For question 2, we have h of x equals sine x over e to the x. So here, we're going to let u equal our numerator function sine x, and we have v is equal to e to the x. So then what we have next is u prime. The derivative of sine is cosine, and the derivative of e to the x is just e to the x. So when we want to find the derivative of the function h, now we just apply the quotient rule. So we have vu prime, that's going to be e to the x times cosine x. And then we're subtracting, we have uv prime, that's going to be e to the x times sine x. Now, when you're using the quotient rule, just know the order of v and u prime is okay to switch, but you cannot switch vu prime with uv prime. If you mess up the order here, that's going to make your answer off by just the negative. So just make sure these terms here are in the right place. So then v squared, our denominator, is e to the x. So that's being squared. And if we simplify this, on top we could factor out an e to the x, and we'll have cosine x minus sine x. And in the denominator, I'm going to write e to the x squared as e to the x times e to the x, because then it's easier to see here that e to the x is going to cancel, that we could get rid of one of the factors. So then our derivative simplified, we're going to have just cosine x minus sine x all over e to the x. So this is our derivative for the next example here. We'll just make that a little neater. Now, the third example here will show some of the trouble we're going to run into when we use the quotient rule. And defining the u and v term is not too bad, but sometimes it's the algebra that's going to give us trouble at the end. So here, notice we have u prime, the derivative of 4x minus 3 is just 4. And the derivative of v, 3 minus 2x, is just negative 2. So when we want to find g prime of x, we're going to use the quotient rule, but the challenge is probably going to be in the simplification step. So we have v times u prime, and that's going to give us 3 minus 2x, which we'll write in parentheses, times 4. And then we have minus, and now we have 4x minus 3 times negative 2. So I'm going to write the negative 2 first. We have negative 2 times parentheses 4x minus 3 over the denominator is 3 minus 2x, and that's being squared. So one of the problems we could run into right away is with this minus minus, is just know that negative, well, when we have minus minus 2, that's going to change to a plus 2. So what we have next, we could write, we have 3 minus 2x times 4, and now we have plus 2. So this changes to addition, and we have 4x minus 3. And this is over 3 minus 2x squared. So then if we really want to simplify this nice, what we should do is distribute and see if we get terms to cancel out here. So we distribute the 4, and we're going to have 12 minus 8x. And now when we distribute the positive 2, that sign change is very important. Now we have a plus 8x, and we have a minus 6. And once again, this is all over 3 minus 2x squared. So we've got 3 minus 2x squared. But if you notice, minus 8x plus 8x cancels out. And now you have 12 minus 6 is equal to positive 6 over 3 minus 2x to the second power. And that's our answer to the third example. So just be careful when you do some of these. You have to be very careful with the simplification step. And you can see in this case, it simplifies really nice. So now we'll look at an example where the algebra is even more tricky to deal with. So for this one here, we have u is equal to x squared plus 10x plus 25, and v is equal to, we're going to have x squared minus 10x plus 25. And we're going to pretend for this question that we don't know the chain rule yet. And the derivative of u is going to be 2x plus 10. But one thing I want to do ahead of time that's going to help us is know that u I could also call x plus 5 times x plus 5, or I could call it x plus 5 squared. And when we look over here, v prime would be 2x minus 10. And if we just take that extra second to factor everything, v could also be called x minus 5 squared. And then u prime we could also call 2 times x plus 5. And v prime we could call 2 times x minus 5. Now, this is going to help us out because now when we apply the quotient rule, we could say that p prime of x is equal to, and we're doing v times u prime. So we're multiplying this term here, u prime, by v. But it's better for us to use the completely factored form. So we would have 2 times x plus 5 times x minus 5 squared. So we're just multiplying these here. Next, we're going to have u times v prime. That's what we're subtracting next. So we have minus x plus 5 squared times, and we have 2 times x minus 5. And this is all being divided by v squared, and v is x minus 5 squared. So we just have to remember to write the square twice because this is going to affect our final answer. So now what we have here in the next line, we just have to do this very carefully. We're going to factor out a greatest common factor here out of the numerator, and that's going to tell us that we have p prime of x equals, and the greatest common factor, so let me just get rid of this piece here, and we'll write our greatest common factor off to the side. So our greatest common factor in the numerator is going to be 2 times x plus 5 times x minus 5. So we just need to factor this out. We have a 2 and x plus 5 and x minus 5, and then you just have to think about what's left. So on the first term here, if we only take out a 2x plus 5, x minus 5, we're going to have an extra x minus 5 left. And now we have minus, and think about the second piece here. If we take out 2 times x plus 5 times x minus 5, this x plus 5 squared has an extra factor of x plus 5 that gets left behind. And this is all being divided by, we're going to have x minus 5 to the 4th power, because we have x minus 5 squared, and then we have it squared again, so we're doing 2 times 2 is 4. So when you look inside this big parentheses here, you're going to have x minus 5 minus x plus 5. When you do x minus positive x, these terms cancel. And when you do minus 5 minus positive 5, that's going to make a minus 10. So this leaves us with 2 times x plus 5 times x minus 5. And then inside the parentheses, we were left with negative 10. And this is all being divided by x minus 5 to the 4th power. So if you notice here, we have factors of x minus 5 that could cancel. We could cancel out one of these, and it's going to reduce the denominator factor to a power 3. So now we just have to write out our final answer here. P prime of x, fully simplified, we have 2 times negative 10, that's negative 20, and we have x plus 5 left in the numerator. Over in the denominator, we have x minus 5 to the 3rd power. So here's our factored and simplified answer to the 4th question. Now, question 5 I threw in as a decoy because we don't actually have to use the quotient rule. Just because we have fractions in our original expression doesn't mean we always have to use the quotient rule. So what we could do in this question is actually rearrange things algebraically. We could call the first term 3x to the negative second. And this, imagine that invisible 1, we could write as minus 1/3 times x squared. So now for this question, all we have to do to find the derivative is use the power rule. And we have negative 2 times 3 is negative 6x, and then negative 2 minus 1 is negative 3. And then we have minus 1/3 times the derivative of x squared is 2x. So when we do 2 times 1/3, we're going to get 2/3, and then we just write our x to the first. So we could stop here. If you want to write everything with positive exponents, you could also say negative 6 over x to the third, and you would have minus 2x over 3 if you want to write it in the form that the question started with, but either of these is okay. Okay, well, this is going to conclude this video on using the quotient rule. If you found this video to be helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comments section below. And thanks for watching.